Good morning, viewers. How many tetrahedral voids are there in a unit cell? How many atoms make one cubic hole? How many octahedral holes are there around an atom in a unit cell? To understand these points, we have to learn about voids or holes in crystal structures. So today's topic is holes or voids in crystal structures. In solids, the particles are closely packed due to strong attractive forces. Atoms, ions, or molecules are closely packed. In doing so, they leave some spaces in between them. So these spaces are known as voids. These voids are classified as trigonal voids, tetrahedral voids, octahedral voids, and cubic voids. So let us see in details. First one is trigonal void. A trigonal void is formed by three spheres. So these are the three spheres, and this is the empty space that is created by these three atoms. So this open space is known as trigonal void. Now if you open up these three atoms, it looks like this. Now if you join these atoms by using an imaginary line between the nuclei of these three atoms, you will get a triangular shape. Tetrahedral void is formed by four spheres. A planar triangle of spheres capped by another sphere forms a tetrahedral void. These are the three atoms lying in a single plane. They belong to one layer, and this is the other atom that is sitting in the triangular void that is created by the three atoms present in the first layer. So this is known as tetrahedral void. Now if you open up these atoms, the arrangement of atoms looks like this. Now the empty space between these four atoms is called as tetrahedral void. Now if you join the imaginary line between the nuclei of four atoms, then you will get a tetrahedral shape like this, and the empty space is known as tetrahedral void. This becomes the tetrahedral void. Octahedral void is created by six atoms. Two planar trigonal of spheres projected in opposite directions will form a octahedral void. So here there are six spheres. Layer. First layer, second layer. Now the empty space created by these six atoms is known as octahedral void. This is octahedral void. So now let us expand these atoms so that the structure will be more clear. So if you slacken this structure, you will get the arrangement of atoms like this. Here you can see the empty space between these six atoms. This is known as octahedral void. And if you join these nuclei by using imaginary lines, then you will get octahedron shape like this. So this is octahedral hole created by six atoms. Cubic hole is created by 8 atoms. So these are the 8 atoms. 4 atoms are there in the first layer. 4 atoms are there in the second layer. The empty space between these 8 atoms is known as cubic hole. So this is how the arrangement looks like. And if you join these nuclei by using imaginary lines, you will get the shape of a cube. like this. Now this is cubic hole. Number of voids around each atom can be calculated by using the formula number of voids around each atom divided by number of atoms around each void. So number of voids per atom is equal to number of voids around each atom divided by number of atoms around each void. Number of trigonal voids is given by 24 by 3 because each atom is surrounded by 24 trigonal voids and each trigonal void is created by 3 atoms. So 24 by 3, that will be equal to 8. So there are 8 trigonal voids per atom. Number of tetrahedral voids is given by 8 by 4 because each atom is surrounded by 8 tetrahedral voids. Let us consider an atom which is present in the corner of a cube. So the corner is shared by 8 unit cells. So how many corners will be nearer to this atom in the corner? So there will be 8 corners nearer to this. And you know tetrahedral void is nearer to the corner. As there are 8 corners around each atom, there will be 8 tetrahedral voids. Now how many atoms form tetrahedral void? 4 atoms form tetrahedral void. So what is the calculation now? 8 by 4. So that will be equal to 2. So what is the ratio of tetrahedral voids to number of atoms? That is 2:1. Number of octahedral voids is given by 6 by 6 because 6 atoms make octahedral void. So how many octahedral voids are there around each atom? Each atom is surrounded by 6 octahedral voids. Now number of cubic voids is equal to 8 by 8. So 8 atoms form cubic void. And how many voids are there around each atom in a cube? Suppose if you consider the atom that is present in the corner, that is shared by 8 unit cells. So one atom in the corner is surrounded by 8 body-centered atoms of other unit cells. So the number of octahedral voids around each atom is equal to 8. So 8 by 8 is equal to 1. So if you are not clear with this calculation, then you can follow the topic location of tetrahedral and octahedral voids where I have explained by using the diagram. Total voids in a unit cell. There are different types of voids in a unit cell. And each type can be calculated by using the formula. Number of voids is equal to effective number of atoms into number of voids per atom. So that will give number of voids of that particular type in a unit cell. So that is equal to Z into N, where Z is effective number of atoms present per unit cell, N is number of voids per atom. So number of tetrahedral voids is given by Z into number of voids per atom. How many tetrahedral voids are there per atom? So here we have calculated number of tetrahedral voids per atom as 2. So we will substitute the same thing only, Z into 2 or 2Z. Where Z is effective number of atoms. Suppose if you take FCC, the effective number of atoms is 4. So 2 into 4, that will be equal to 8. So FCC contains 8 tetrahedral voids. Even in HCP also, you will get the calculation like this only. The number of tetrahedral voids will be twice the number of effective atoms. So here there are 4 effective number of atoms in FCC. So that is why 8 tetrahedral voids we are obtaining. Similarly, number of octahedral voids is given by Z into N. What is N? N is number of octahedral voids per atom. So number of octahedral voids here we have calculated as 1. So now number of octahedral voids will be equal to Z into 1, or that is equal to Z only. So number of octahedral voids will be equal to effective number of atoms in any unit cell. For example, in FCC, octahedral voids is equal to effective number of atoms, so that is 4 into number of octahedral voids per atom, so that is equal to 1. So that number obviously will be equal to the effective number of atoms only. So as there are as many octahedral voids as the number of atoms either in FCC or HCP. Location of voids. So here we'll see about the location of tetrahedral voids and octahedral voids. So let's begin with the location of tetrahedral voids. So let us consider face-centered cubic unit cell. So this is a face-centered cubic unit cell in which 8 corners and 6 faces are occupied. These are the 8 corners and 6 faces. 1, 2, 3, 4, 5, 6. So this is the structure of face-centered cubic. So tetrahedral void is created by 4 atoms. So this atom that is present in the corner along with 3 atoms present in the faces, they will form tetrahedral void. So what are the 3 adjacent faces? So this is one face, this is the other face, and one more face is front face. Okay, so this one will form a tetrahedral void with so this is a planar trigonal of spheres capped by another atom. So this is the corner atom that sits in the trigonal of void that is created by these 3 atoms. So this becomes a tetrahedral void. So 4 atoms form tetrahedral void. So this is tetrahedral void created by 4 atoms. So similarly, if you take this corner, okay, these are the 3 atoms adjacent to this corner atom. So they are present on the adjacent faces. So they form the trigonal of void, and this atom sits in the trigonal of void. So these 4 atoms form another tetrahedral void. Similarly, this atom forms tetrahedral void by using 3 more atoms on the faces. Okay, this and this. Similarly, this one forms tetrahedral void by using the 3 atoms. Okay, what are the adjacent atoms? This one, and this one. So like this, any corner has one tetrahedral void. So as there are 8 corners, here there are 8 tetrahedral voids. So what is the effective number of atoms here? Effective number of atoms is equal to 4. So number of tetrahedral voids is equal to twice the effective number of atoms. So as there are 4 effective number of atoms, number of tetrahedral voids will be equal to twice of it. So that will be equal to 2 into 4 or 8. Now we'll see octahedral voids. For this also we'll consider FCC, face centered cubic unit cell. Here again we have taken face centered cubic unit cell, but this time the face centered lattice is formed by chloride ions, whereas the voids are occupied by sodium ions. So this is sodium chloride crystal. Here the chloride ions are forming FCC. So they are present in the corners and on the faces, whereas Na plus ions are present in the body centered position as well as on the edges. So here sodium ions are present in the body centered position and in the edges like this. And if you observe each Na plus ion, that is surrounded by 6 Cl minus ion. Observe this. This is present at the body centered position and it is surrounded by 6 Cl minus ions. 1, 2, 3, 4, 5, 6. So actually 6 Cl minus ions are forming octahedral void. So here Na plus ion is present in the octahedral void created by chloride ions. And again, even if you consider this Na plus ion that is present on the edge, so that is also considered to be present in octahedral void. So even if you consider this ion, this sodium ion, that is also surrounded by 6 Cl minus ions. How? This is one ion, this is another ion, third, fourth, and where are the other two ions? So the other two ions, just if you go along with this line, you will find here. So that will be the face centered atom of another unit cell that is present just behind this unit cell. So there is another atom on the adjacent face here. So similarly, if you proceed along with this, you will locate another chloride ion here. So that is also adjacent. This chloride ion will be present on the rear face of another unit cell that is present beside this unit cell. So there is another atom here, another atom here. So even this atom is also surrounded by 6 other atoms or ions. Okay, so even this sodium ion is also present in octahedral void. So Na plus ions are present in octahedral voids created by chloride ions. Similarly, even chloride ion is also present in octahedral void. Suppose if you consider this chloride ion, this is present in octahedral void. So here you can see 1, 2, 3, 4, 5 and one more atom or sodium ion is present here, that is present in the body centered position of another unit cell just in front of this unit cell. So in total 6 ions, Na plus ions are present around this chloride ion. So even this is also present in octahedral void. Okay, now we'll calculate number of octahedral voids for this unit cell. Unlike tetrahedral voids, the octahedral voids are under sharing. So this is not shared by any other unit cell, and this tetrahedral void belongs to only this particular unit cell only. Whereas if you consider this octahedral void that is present on the edge, that is shared by 4 unit cells. You know, edge is shared by 4 unit cells. Similarly, octahedral void which is present on the edge is also shared by 4 unit cells. So we have to calculate number of octahedral voids on the basis of their position. Suppose if you take this one that is present in the body centered position, it is not shared by any other unit cells. So the contribution becomes 1. So how many body centered positions are there? 1. 1. And contribution to 1 unit cell is 1 since it is not shared. So 1 into 1, so that will be equal to 1. Now where are the other octahedral voids? They are present on the edges. So how many edges are there? There are 12 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 edges and each edge is shared by 4 unit cells. Each edge is shared by 4 unit cells. So what is the contribution of this octahedral void to one unit cell, so that will be equal to 1 by 4. So number of octahedral voids per unit cell present on the edges will be equal to 3. So what is the total? Now total is 4. So number of octahedral voids is equal to effective number of atoms, that is Z. So a unit cell contains as many octahedral voids as the effective number of atoms or ions. So number of octahedral voids will be equal to 4. Earlier I asked you few questions. So let's see the answers before we conclude this lecture. So the first question. How many tetrahedral voids are there in a unit cell? Number of tetrahedral voids is twice the effective number of atoms present in a unit cell. Suppose if you take a face-centered cubic, effective number of atoms is 4. So twice the number of these atoms, that is 8. 8 is the number of tetrahedral voids present in face-centered cubic. So the second question. How many atoms make one cubic hole? 8 atoms make one cubic hole. Third question. How many octahedral voids are there around each atom in a unit cell? Each atom is surrounded by 6 octahedral voids. That is the answer.